Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. In a good occasion, let me to present my article with title Feasibility of Integrating Self-Regulated Learning in P6 STEM Module to Train Creative Thinking Skill. First one is introduction. The introduction, it can be shortened by mind map of this research. 21st century demands person brains with have 4 C skills. One of them is creative thinking skill. And creative thinking skill, it can increase by STEM learning. And besides that, because of 21st century demands, it requires improving the quality of education in Indonesia, so that there is an improvement to the curriculum. And the curriculum is implementation in all schools in Indonesia. One of them is junior high school at Islamic boarding school in Pati, Central Java. Short meal achieving the target of formal education and TOEFL. So it need optimization meal formal education and then need meal self-regulated learning. So it's provide meal learning module. And because of them, so in this research, I take a research development of self-regulated learning in P6 STEM module to improve student creative thinking skill. And then method. First is research design. This research used mixed method with a sequential exploratory design by Creswell and Creswell. And it can see by figure 2. The qualitative phase, data collection and analysis, then builds into the module. After that, quantitative phase, there is instrument design. And after that, qualitative phase and quantitative phase, it will be interpretation. However, in the study, only arrived in the feasibility of integrating self-regulated learning in P6 STEM module, so it emphasizes more on qualitative data. And the second is participant. The participants who involved in this research were 3 lecturers of expert validator. 3 lecturers of expert validator participate in validating the module feasibility. Third, instrument. The module validation sheet was used to assess the feasibility of integrating self-regulated learning in P6 STEM module. Fourth, data analysis. The icon validation technique is used in the expert validation module feasibility analysis. The icon formula is V equal sum S divided by N times C minus 1. And in the table 1, the validation result criteria is can see in category very high, moderate, low, and very low. Then result and discussion. First one is analysis of needs. In this research, analysis of needs cover of the application of STEM learning, module need, scope of material that needs to be developed, the importance of self-regulated learning, the efforts that can be made to improve creative thinking skill. And then the feasibility of integrating self-regulated learning P6 STEM module. The feasibility of module includes 3 components are the material suitability with STEM, the module conformity with self-regulated learning, and then the feasibility of teaching materials. And there are also the module improvement by expert. From the validator 1, the improvement suggestions are there are still some typo that need to be edged of engineering aspect, and all of already repaired. And from validator 2, there is no revision. And from validator 3, the improvement suggestion is R. At time calculation process, at rock component that make up the mirror, at electron microscope, use the orange again as self-regulated learning color to be changed to yellow. And all of them are already repaired. And then the feasibility of the model. First is the material suitability with stamp. The first validation is 0.88, category very high. Number 2, the module conformity with self-regulated learning. The validation is 0.87, and the category very high. And the third, the feasibility of teaching material. There are three parts. The first is the dimension of attitude, knowledge, and accuracy of the material. The validation is 0.88, and the category is very high. Then module presentation, the validation 0.186, the category is very high. And the last is language, the validation is 0.88, and the category very high. And the conclusion of this research is the feasibility of self-regulated learning P6 time module is in very high category. For a component of the material suitability with self have a validation value of V equal 0.88 in the very high category. Then the component of module conformity with self-regulated learning has a value of V 0.87 in the very high category, as does the instrument the feasibility of teaching material, which has an average validation value in the very high category. So the module can be tested on the student for readability and widely implemented.